All right, let's go on to the next question. So here we're asked, a box with a square base and open top must have a volume of 8,000 centimeters. So this is probably a typo. It should be 8,000 centimeters squared. Find the height of the box that should be used to minimize the amount of material used. So we have two terms that we need to define. So we have volume is equal to something, and then we have surface area is also equal to something. And we're trying to minimize the surface area and find the height of the box. So we have a term h that we need to find the value for when the volume is 8,000 centimeters squared. So to start off, to define the volume, it's the base, the area of the base times the height. So the area of the base, since it's a square base, it would be x squared, and then the height would just be h. So I'll just draw a diagram. So we have some box. So we don't know the height, but we know the base is x times x. So x times x is x squared times the height gives us the volume. The area, so some information given in the question, it says it's an open top. So there's no area on the top. It's only the four sides and the base that we're calculating. So the area of the box would be x squared. So that's the base. And then we have to add 4 times each side of the box. So x times h. So now we've derived two equations based on the information provided in the question and defining some variables. So now we can substitute the volume given to find the value for height. So here we have 8,000 equal to x squared h. And we're going to isolate for h, and we're going to use h to substitute into equation 2. We'll call this 2, we'll call this equation 1. So h is equal to 8,000 over x squared. Okay, we'll substitute this into equation 2. So we know area equal to x squared plus 4x times 8,000 over x squared. And now we can simplify this even further. X squared plus, so 4 times 8 is 32, so it's 32,000 over, we have 1 x on top and 2 x's on the bottom, so we are left with 1 x on the bottom. So x cancels out one of the x's on the bottom. Now we've found the equation for area in terms of x. Now to minimize the surface area, we want to find the value of x when we take the derivative and set that to 0. So we'll take the derivative. So we'll leave this equation here. I'm going to erase the rest of the board. So 1 second, let me just get that back. I'm just going to erase a bit of the board. So I'll erase this top part. Okay. So the derivative of a is equal to, so x squared, the derivative of x squared is just 2x plus, and the derivative of 32,000 divided by x. So to look at this with derivative of 1 over x is equal to the derivative of this is equal to 1 negative over x squared. So this is just kind of a derivative law that you should know. So knowing this, then you know there's going to be a negative sign, not a positive sign. So we get negative and then 32,000 over x squared. Now we are going to use the denominator of the second term to multiply 2x by x squared over x squared, and we'll get 2x cubed, and this is over x squared, minus 32,000. Now that we've kind of gotten the derivative of the surface area into a format where we can set this to 0, so we'll set it to 0 to find the optimum x value. So here we multiply both sides by x squared, and we're left with 2x cubed minus 32,000 equals 0. And then we have 2x cubed equals 32,000. And then here we have x cubed equals 16,000. You can see that x is equal to 10 square root 16. So because we have 1,000, we know that the cubed root of 1,000 is 10. So we put that on top, and then we're left with the 16 term to the square root of 16. We can simplify this even further, because you know the square root of 16 is 4. So we get 10 times 4, which is 40. So when we have a large square root, or cubed root, oh sorry, this is not, sorry, this is incorrect. So we're looking at the cube root of 16, not the square root. So cube root of 16. So yeah, you can't really minimize that any further. So we have the x value here. We'll get, we can kind of calculate it in our calculator, and we'll find, so 10 times the cube root of 16 will give us 25.2. So knowing this, we can substitute this value into the original equation to find the value of the height. So now at x equals 25.2, we have potentially the minimum of the surface area. So to double check that this is the minimum, we can take the second derivative of the equation and try to see if it's we set it to a positive or negative value. So here we take the second derivative of this equation, and we see that it's 2 plus 32,000 over x cubed. So the first term is straightforward. The second term, you have negative 1 over x squared. So negative 1 over x squared, the derivative of that would be 1 over x cubed. And then you have just the 32,000 on top. So if we substitute 25.2 into the x here, we can just plug this into our calculator. So we have 2 plus 32,000 divided by 25.2 to the power of 3. We'll get approximately 4. So approximately 4. So since this is a positive value, we know that the function that the area represents will be concave up. So when we take the second derivative, we know that if it's a positive value, that means the function that the area represents is positive up, which means that this is a minimum. So the value of x that equals 25.2 is a minimum. So when the second derivative is positive, we know that the value for x is equal to a minimum. So we've kind of just double checked that this value is actually a minimum. So we'll clear the board here. So we'll clear the page. We know that when x equals, let me just double check this. So the value we got was 25.2. So when x equals 25.2, we know at this value we get the minimum surface area. So we have the equation height equals 8,000 over x squared. And we know at this, when we substitute x, so 8,000 over 25.2 squared, this gives us, we'll plug this into our calculator, so 8,000 divided by the square root, divided by 25.2 squared gives us 12.6 approximately. So we'll do squiggly equals for approximately. So when the height equals 12.6 centimeters, we know that the minimum surface area is used when the volume is equal to 8,000 centimeters cubed. Sorry, not squared, 8,000 centimeters cubed. So looking at this solution, the volume of the box is from this. We can obtain the surface area of the box volume. So kind of gives a process. It doesn't show a complete solution. We have a file. Let's see what the file says. Go to save. Okay, so the file is just giving us the question. Okay, so here the solution is not present. Solution is not present. Correct description of process. Correct answer is when the height equals 12.6 centimeters, minimum surface area is used at a volume. So our constraint was the volume needs to equal 8,000 centimeters cubed. So the solution is incorrect. So that's all we had time for today. Hope you enjoyed the questions and the answer solutions. If you have any more questions, you can always go on oneclass.com for your tutorial needs and any homework help, and where you can submit more questions that you're struggling with. Thank you for tuning in, and hope to see you in the next session.